Yeah, perfect. Okay, so now we're recording again. Excellent. All right, thanks everyone. So let's go back. We're going to share the screen again and share that guy. All right, give me 1 second. They're vacuuming outside. Can you stop for now? I can't hear when I'm doing a class in here. Can you come back in 20 minutes? That's okay, thank you. All right, sorry about that, everyone. All right, we're back. Okay, good. So, yeah, we should be sharing a screen now. Excellent. So, so we did extracting the by positions. We extracted the second column. We can also extract based on the name of the column. All right. So you use the double square brackets, and then you use the name of the column in quotation marks. All right. Here's another way to extract data. You use the $sign. All right. That is often easier to do. And actually, so it gives you the same result. And there's, as I'm sure you've probably seen, there's this little shortcut here. If you type in the $sign, it gives you this little menu where you can pick what you want to get. Okay. So that's a useful thing if you're doing sort of interactive working with the data. All right. So good. So that's that. Next, other data types. All right. Actually, yeah, things are a little bit out of order here. That's okay. So actually move this up here. So let's talk about lists for a second, then we'll go to subsetting. So a list is useful. A list is like a generalization of a vector. All right. So if you are you want to put different data types together in the same object, that's what you use a list for. So you can see here, if I make a list with the 1 and these other characters in there, I get now something different, and it lets me keep 1 as a numeric value rather than converting it into a character. Okay. So lists are super useful. They're super flexible, meaning, if you're doing a lot of calculations, putting a lot of things together with your project. Sorry about that. Okay. If you're putting a lot of things together for your project that are different types, let's say different types of tables, or a plot, or different variables, you can put those all together in a list, and then save that one list as opposed to having 10 different objects together. So lists are very flexible and useful. Even more useful is to name the objects in your list so you can keep track of what they are. So it's not just the first object, it can actually have a name. All right. So that's what this names command does. So whenever I make a list that I'm going to be using for a while, I always put names on it. Okay. And so you can see now if I run demo list again, now we have a number, a letter, and a name. Okay. So that's a useful organization trick. You can then extract these values using the same $sign operator that we used on Tibbles and data frames. So that sort of clues you in that they're similar sorts of structures. Okay, so subsetting. So extracting is pulling out a component and looking at it and working with it as a different sort of component from what the original thing was. Subsetting is just making a smaller version of the original value. All right, so to subset, instead of using the double brackets, you're going to use the single square brackets. Okay, so that's what I'm showing here. For a two-dimensional object like a data frame, you're going to use a row, comma, column notation. So what this is telling us is that we want to get the second and third columns out of demo data and return it as a data frame, okay, or as a tibble. And so that's what that does there. So we've got the second and third columns, and we can also take the first and second rows. So you got to remember, it's always row, comma, column. That's across everything in R. So that gives us the first two rows of that data. The next thing that we can do is we can subset based on names. Okay, just like we can select or extract based on names, we can also subset. So this will give us the two columns: name, species, and observation. All right. You can do the same thing for a list. So I'm not going to go through that because that's pretty obvious. All right. So now that we've, are able to subset and extract values from our data, we want to do something with it, obviously. All right. So probably first thing you want to do is calculate an average, right? So we know that demo data is numeric value, so we can calculate an average, the mean, for example, of those numbers. So it's very easy. You just use the command mean on that vector. So mean is a vectorized command, meaning that it will take, one value, two values, 10,000 values, and operate on them very quickly to produce a single value, which is, in this case, is the mean. All right. So those are very efficient functions in R. Okay. So that's the mean. That's very easy. All right. You can also add two vectors. Now, when you add vectors, you get vectors back, right? So what's it going to do? It's going to take the first value here, add it to the first value there, second value, add it to the second value. So these are sort of typical like linear algebra, very basic type operations, but you can do that. So 1 + 2 is 3, 2 + 3 is 5. So don't be confused. That's not 35. That's a two, a vector of length 2, first value 3, second value 5. All right. There's a concept of recycling. So if you try to add vectors of unequal length, the smaller one will get recycled and added in until you get through all the larger ones. All right. So remember that a single value is a single element vector, and that's going to get recycled 3 times when you add it to 1, 2, and 3. So you're going to get 2, 3, and 4. So that maybe is a pretty useful thing. This, if you do this where they're not, evenly divisible, the length of this is not evenly divisible into that one, that's potentially a risk. And so you would want to avoid something like this, because what it's going to do is going to add 1 to 1, 2 to 2, then it's going to go back and start here and add 1 to 3. And that's sort of like not really a useful thing to do. So it actually is going to give you a warning that you've done something that doesn't really make sense. So that is, but just know that's how that works. Okay. Another thing that you're going to want to do eventually is comparisons. Okay. So greater than, less than, is the same as, is different than, these sorts of things. And there's a list of operators that you can use to do this. I've linked to some nice references in the website where you can find these things. But you can also just Google for R operators, and it will give you a list of all the different sort of comparisons and tests that you can make. These are going to be, say, like, why do I want to do 1 greater than 0? Well, you're not going to do that. But what you're going to do is you're going to calculate some value and then calculate another value, and then you're going to want to compare those more complicated values. And you maybe even want to use that inside of a more complicated function to say, all right, if this is equal, or if this is greater than, or if this is less than, then do something different. So, but these are the fundamental basic, building blocks for you to be able to do that. All right. So, all these comparisons, they return a single value of true or false, depending upon what it is. Okay. All right, so these are all sort of base functions. Now, quickly, I'm going to go through some more techniques using the tidyverse functions. We added the tidyverse, we basically attached that to our session. It's, when you're starting out, it's like, oh, do I need to learn like all this additional stuff? And the answer is kind of, because it's actually much better. It's more fluent, to use a sort of a complicated word. It's easier to read and understand what's going on compared to the base functions. And so I think you'll want to move towards using the tidyverse style functions very quickly once you start to work with your data. All right. And one thing they allow you to use is these pipes. And pipes are great because essentially they transfer data from one function to the next. And if you took programming a long time ago, or we're using like BASIC or COBOL or something like that, there's a lot of like brackets and parentheses and nested parentheses and things like that, which are very difficult to interpret. This takes all that away and allows you to pass values serially from one function to the next. Okay, so let's say what we want to do is we want to add a new value onto our demo data table. All right, so what's going to happen here is we're going to start with that data, and then we're going to pass it to this mutate function. Mutate's going to create a new column with this name, and that column is going to be created with this value. All right, whatever function or whatever statement I want to put on the right-hand side of this equal sign will become the value for each row in the new column. All right, so I can run that much. All right, and I get this, okay, which is the length and width, which is the sum of that column plus that column. All right, so 5.1 plus 3.5 is 8.6. Great, so that worked. Now, let's say that's a value we're interested in, but we want to compare between species. All right, so species is like another character value, so we can actually tell R to group those. That doesn't do a whole lot by itself. You will notice that we've now got a group value in here, group by species. That's a new thing. But then when we run summarize, what that's going to do is it's going to calculate an overall average based on a particular column. All right, so this is a new column that we're going to make, and it's going to be calculated as a single value, which is the mean of the this sepal LW thing that we added. Okay, and it's going to do this by group. Okay, so we've grouped, and it's going to do this within groups. So we have 3 groups. We should get 3 values out of this. So we can run that. Okay, great. So we got this value for each of the groups that we've identified. Okay, hopefully that makes sense. That's something that you're going to use like on a daily basis to get summary values out of your data between treatment groups, between patient groups, whatever you're working with. Okay, so there is a vast array of functions and resources for you to understand these functions for the tidyverse. And all you need to do is basically Google like tidyverse cheat sheets, and it will give you like these sort of pretty dense but useful PDF files to know what these commands are doing. But let me run through a few of the more common ones. Select is what you use to select columns from your data. So it's similar to the subsetting by column using the base functions. All right, so let's say we want to take everything except for the observation column. That's how we do that. So we have the same tibble, but we've lost the observation column. We can also positively select things like so. Okay, so very easy to follow. Okay, filter is how we more or less select or filter rows. Okay, so select is for columns, filter is for rows. And here we're going to use a logical test where we only filter or only keep the rows where species is equal to this setosa value. Okay, so you can run that, and you can see here we've now got 50 rows, and they're all going to be setosa. All right, so that's like super useful as well. We can also have it meet more than one, be more than one value using this in operator, and so we can run that again, and you can see that there's 100 rows, and so it's going to be the 2 that we've selected there. So you want to, these are very common things that we use. One concept which can be a little bit difficult, I'm going to try and get through these here before the end, is pivoting. So sometimes in some settings, your data is going to be, you're going to want to put things into all of the values that are of a similar type into a single column. All right, and so you'll remember if we have the demo data, okay, we have these 4 numeric columns here: length, width, and width. Okay, and let's say we wanted to put all those together in one column, but then have another new description column for what value those are. And that's what you can do with this pivot longer command. All right, so let me run that, and we're going to identify which columns we want it to pivot. And these are all going to be these numeric columns. Okay, and so now you've got everything here. So now the name, which was previously the title of the column with that numeric value, is now in this name column. And the value, which was the value, is now in a specific value column. All right. So this is a little bit maybe sometimes hard to take some playing around to figure out. But that's very useful when you go to have different plots and different calculations that you want to make. The computer is going to work a lot better with the data in this longer format. Okay, so that's, if you ever see pivot, that's what it's doing. You can also reverse that operation with this pivot wider command. Okay, and so all that does is just returns things to where they were. All right, so let's do a few more things here. I'm going to show you, the last thing I'm going to show you is a join. All right, so super common that we do this. It's similar to like a VLOOKUP or an HLOOKUP in Excel that you might have tried in the past, but basically we're going to take two different tables and literally join them together by a common column. All right, so let me demonstrate. So we make the sepal data. All right, that's just those sepal values there. And we take the petal data, and that's just the petal value there. And you can see that they have a common column name here, species, and they have common values in that column. All right. And so what it's going to do when we tell it to join, it's going to join those two little tables together. And it says joining by species. And it's going to then put all those values together in the correct order. Okay. So this is a super common thing that we do. You always want to make sure that things are joined correctly, that you don't have missing values or duplicated values. You really have to be careful with that. But that's an important skill to know. All right, so we're at 11 o'clock, so we're going to call it a day. Let me bring back my notes here. What I want you to do is I want you to make your own version of this week 2 file in your R project and try running the code that I put on here. Then take data from your own experiments, reformat it, read it into R, and try doing different data manipulations using either the base R or basically using the base and the deepler functions. Okay, and then you're going to try comparing. I want you to try and comparing groups. I didn't show you exactly how to do this, but try extracting values and comparing groups using things like t-test and the Wilcox test. All right, and all you do is you take out the values that you want by subsetting and extracting, and then feed those vectors into those functions. Okay, and that'll be it. We'll go over the joins when we start the next session, because I know we went through that pretty fast. Again, thanks everyone. Sorry for the technical difficulties, and good luck. And yeah, post any questions that you have in the issues section on the website, and we'll get to them when we can, as quick as we can. All right, have a good week. Bye.